Problem 6. I have a right triangle here. The leg opposite angle alpha would be the 6. The leg adjacent to alpha would be the 8. The hypotenuse is the side opposite the right angle, which would be 10. Let's see, the ratio of the opposite 6 to the hypotenuse 10 would be 6 over 10, which reduces to 3/5. The ratio of the hypotenuse to the adjacent 8 would be 10 over 8, which reduces to 5/4. If the other angle is called beta, can I find the sum of alpha and beta? And the answer is yes. All three angles have to add up to 180. I already have a 90-degree angle. 180 minus 90 is 90. That leaves a total of 90 degrees for the other two angles. Well, angles that add up to 90 degrees are called complementary angles. Problem number 7. Let's see, when I multiply, I want everybody to look like a fraction, so I'll put a 1 there. And I'll see about doing some cross-canceling. I can divide out these 3's. I can also divide out this common factor of 5. And so after doing all of that, all I see on the bottom are 1's. I don't even have a fraction anymore. And on the top, I have 1 times 1 pi times 4. That's going to be 4 pi. Again, it's not even a fraction. There's my final answer. Part B, dividing by 1/2 is the same thing as multiplying by the reciprocal of 1/2, namely 2 over 1. And now I can do some cross-canceling. And when I multiply across, I end up here with 3 pi on the top and 2 on the bottom, 3 pi over 2. In part C, for subtraction, I'm going to need a common denominator. Looks like 12 is the smallest number that both 6 and 4 go into evenly. So I'll fix this one with a 2, and I'll fix this one with a 3. That gives me 10 pi over 12 minus 3 pi over 12. Subtract the tops. 10 pi minus 3 pi is 7 pi. Keep the bottom the same. 7 over 12 doesn't reduce, and so here's my final answer, 7 pi over 12. Problem number 8. I have a function machine here. I can stick in any number between 1 and 10, and what the function sends out is described here. It squares what I send it, and then it adds 3. So part A, if I put 4 in, what's going to come out? Well, 4 squared is 16, plus 3 gives me 19. F of 6 is how this is read. F of 6 simply means take 6, stick it into the function, and say what comes out. Well, 6 squared is 36, plus 3 would be 39. So we say F of 6 equals 39. Part C is a little trickier. F of x, the output, is 67. So what was the original x? What number was stuck in? Well, whatever it was, I squared it, then I added 3, and I came out with 67. Well, if I solve this equation, I'll know what x is. Subtract 3 from both sides. That gives me x squared equals 64. Take square roots. I know I'm dealing with only positive numbers here, and so I end up with x equals 8. The problem said find x. We did. 8 must be the starting number so that if you find f of 8, you will get 67. Write an equation for the function. Well, we essentially did that in the last problem. My equation, my f of x is like y, is simply x squared plus 3. In other words, what this function does is it takes x's, squares them, and then adds 3. Why could I not find f of 15? I mean, I think I could square 15 and add 3. I could do the math. The problem is that 15 is not a valid input. The fancy way of saying that is 15 is not in the domain of the function. The domain is the list of all allowable inputs, and the only inputs allowed, according to our definition here, were numbers between 1 and 10. Last question. no matter what input you put in, how many answers are you going to get? And the answer is you'll always get simply one output. When we stuck 4 in, we got 19. If we stick 4 in again, we'll still get 19. Every time you put in an input, you get one answer for the output.